All right, so we are going to look at transformations today. We're only going to get through part of this. Don't stop talking. I put a bunch of definitions here mostly because I want you to be aware of what they mean, not so that you regurgitate them. So there is a difference between rigid versus non-rigid transformations. So a transformation is rigid when the size and shape of the graph remain unchanged. Calm. And transformations that create an unchanged graph would be really translations. Moving a graph up, down, right, left, or reflections over the y-axis or reflections over the x-axis. Those are types of translations that keep the graph in its original shape. Whereas non-rigid transformations generally can distort the shape of that graph. You might recall that this used to be called a dilation. It had a scale factor. So we're going to call that horizontal and vertical stretches. That part can get confusing, and that's the part that we're not going to get to today. So if you have anything with vertical or horizontal stretching or shrinking on your homework tonight, don't do those questions. Skip the questions that have that in there. All right, so let's start with vertical and horizontal translations. If you think of a vertical translation, vertical is up, down, right? A vertical line is going up, down. So if I am moving something up and down, is it affecting the x value or the y value? So if I move this point from here to here, does it affect the x value or the y value? The y value. And the y value, remember, is the output for the answer. So f of x is your output. It's what results. So if I want to change the output or your y, I'm going to add something or subtract something to it to create that change. So I don't necessarily believe in memorizing versus understanding. If you understand it, you don't really have to memorize it because you understood it. So I'm giving you some little helpful hints to help you kind of remember these things. What's wrong, Pearson? Are you okay? So when we have a vertical translation, you will see something being added or subtracted outside of the function. Notice that going up generally is a positive number. Well, generally it is. Going up is the direction of positive, right? So it makes sense we'd be adding. And going down is where the negative numbers are, so it makes sense we'd be subtracting. So we use the same sign as the direction that we're going. We're going up, it's a positive. We're going down, it's a minus. Horizontal is a little bit backwards. If you think about a horizontal translation, we would be moving right-left. Horizontal lines go right-left. That can help you remember if you think of a horizontal line, it goes right-left, so that's a right-left direction. However, does that affect the x value or the y value when I go right-left? Or the x value. So to affect the x value, I have to go inside the function to where that x is. The x is inside the function. So notice that we are adding or subtracting this translation amount inside the function. But notice that a plus c gives you a left translation and a minus c gives you a right translation. Typically we think plus, if you're going right-left, would be reasonable to think you'd be going to the right, but it's actually left. And vice versa. These are opposite signs, and I'll show you why. If I were to take the graph that most of us are familiar with, I'm going to clear all of my stuff here. If I took a graph that we're familiar with, y equals x squared, and put that into here, that's what the normal graph looks like, right? So if I were to do y equals, let's just move it 2 places. So if I did x plus 2, so here I'm going to put x plus 2 in parentheses because I'm going inside the function. Look what happens. Here's the original. Didn't it move to the left? So a plus moves it to the left. After many trials and errors, we determined that anytime we add something inside the parentheses, we actually go the opposite direction. And anytime we subtract something inside the parentheses, we go in the opposite direction. So adding is normally a positive direction, but because it's inside, we're going to go to the left. Subtracting would normally be a negative direction, but because it's inside the parentheses, we're going to go to the right. There's something else that you've experienced when we did this. If you think about the equation of a circle, x minus h squared plus y minus k squared equals your radius squared. If I gave you a center of 1, -2, and you put that center into that equation, that x value of 1, didn't it become an x minus 1 inside the parentheses? We changed the sign. And same thing with the -2 for the y value. When you put it in parentheses, it became a +2. Anytime we put something in parentheses, it tends to change signs. So there's another example that you can have. All right, so when you do your Math Excel tonight, I went ahead and kept all the questions because they're all identification questions. There's very little punching of numbers. I would highly suggest that as you're doing it, you graph things on your own. Do not look at the equation here and then look at your graph choices and go, oh yeah, it's that one. I want you graphing it on your paper before you look at your answer choices. When you take your test on Thursday in here, you're going to have to graph it. And if you haven't practiced graphing it, you just practice going, that's the graph that matches, that's the graph that matches, you're going to struggle. Just let you know. So don't do that to yourself. All right, so let's look at this one. We've got, and I didn't have to tell you that it's the y equals absolute value of x graph. You have your 12 basic graphs. Are we all paying attention? What are you doing? She's making lovely, pretty pictures on her styrofoam cup. She's distracting me with her awesome art. All right. So if I gave you this, you've got to recognize without me telling you that the basic function is y equals absolute value of x. And notice that this one down here has a +2 in there, but the overall umbrella function would be the absolute value of x. So you've been given a composite, essentially, and you've got to break it apart to what was the original. And so that's one of the reasons why we did what we did yesterday. So this one, Friday. It's been a long weekend. So I'm going to go ahead, and if I were you, I'm very visual. Most of you are very visual. I'm going to go ahead and I'm going to graph y equals the absolute value of x. What does that graph look like? Looks like a V, right? Starting from the origin. Pretty soon you won't have to plug in values. And if you don't know what the ordered pairs are that makes this graph, start plugging in values for x and seeing what the output is. You should by this time know what this one is, at least, right? If I choose -1, the absolute value is +1, and so forth. Do not connect the dots. So that's my original graph. I'm not connecting the dots because that's not the graph that I want. I want the absolute value of x -4. Is this -4 occurring outside the general function or inside the general function? Outside. And if it's outside an up-down movement or a right-left movement? Up-down, because it's affecting the output. The output is the square root of x. That's our general formula, so it's affecting our answer. So it's an up-down movement. Is it same sign or different sign? Same sign. So we're going up or down? We're going down 4, right? Correct? So every single one of these ordered pairs, all you have to do is move them down 4. 1, 2, 3, 4. This one, 1, 2, 3, 4. Could you plug in a value for x and pop out a value for y? Of course. But that takes so much longer. I mean, really what I would have been doing is I would have found that vertex, I would have moved it down 4, and then your pattern goes from there. But some of you don't have that pattern down yet. So every single one of those points that we plotted earlier, they get moved down 4 units. And now connect your dots. My assumption is that if you have a dotted line, that is not your answer. you have a solid line, that's your answer. If you want to be really clear, I'd actually label it y equals the absolute value of x minus 4, and this one is y equals the absolute value of x. Do you have to put the red one on there? No. But for a lot of you, it's going to be easier to plot the basic graph first and then translate that how you're reading the equation to state. You okay with that? No? Okay. So what happens when we have something inside? So this one's inside. So what kind of movement is that? Up, down, or right, left? Right, left. And why is it left? Opposite sign. So opposite of positive would be left. And we are going 2 units. So I'm going to take that same basic graph that we had before. That's your y equals the absolute value of x, and we're going to move that left 2. So every point gets moved 2. And then make sure you connect, because otherwise I don't know which graph is the right one. So as this graph gets moved further to the right or the left, it starts to look like a check mark because you lose part of the graph. And so if I label this, I have y equals the absolute value of x plus 2. That's a review of 3-4, isn't it? Did you do that in 3-4 last year? You should have. My hope is. All right, let's look at a curve. Curve is a little bit more difficult. So for each one of these, we are going to use the graph of y equals x cubed. Again, you need to start to understand what those ordered pairs are, but if not, we're going to plot the following ordered pairs. We're going to plot 2, 8, 1, 1, 0, 0, negative 1, negative 1, and negative 2, negative 8. How did I get those? Yeah, I plugged my x into the x cubed and I squared it and got the y's. But you're going to be doing enough of this, or you should be doing enough of this, that it just becomes second nature. And so every one of these 3 graphs, I want you to plot those points and put a dotted line through them. So obviously the 2, 8, I'm going to have to go off a little bit. Make sure that you label it. Austin, they're coming to get you. You better hide. What? They're coming to get you. You better hide. You want a helicopter? I'm just kidding. What did you do? My son actually had the Phoenix police helicopter caught one of him. He and his friends were smoking cigars on the top of the roof. All legal but one of them. So they thought they were trespassing. I'm sorry, they thought that they were breaking into the gym. They were only trespassing. Note to self, don't do that. How are you? Oh, okay. I'll take it.
Did you say it was 17?
Yes.
7,700.
Oh.
Okay. So I just want to look at some so let's talk to you.
Okay. Yeah, because I'm not doing anything tonight, so
It's a start. And then I'm gonna make a review of the points based on that really so we can do whatever you want to review. But let's touch base.
that sounds good. Thank you. Okay. So, I forgot my sign. All right, so I want you to plot the following. We're going to do 3 different graphs, and they're all based upon this main graph. And you're going to come up with the equation this time. So we're doing it backwards. You may or may not be given this part that's in red. So when you see a translated graph, your immediate thing should be to put in that original graph so you can see that the graph move up, down, right, or left, or there could be a reflection. We haven't gotten those yet. So plot the following points: 2, 5, 1, -2, 0, -3, and -1, -4. I already know what the points are, so that's why I'm telling you what they are, so that you can graph it. I didn't come up with these my own. I already created the translation. So plot those points. So not all of these points were able to fit on the translated graph, but you can see that these 3 points right here, don't they mirror these 3 points right here? Right? So you should be able to tell that there's a curve going through here, going like that. So what happened from the original to the blue one? Did the graph move up, down, right, or left? Down. And what's easiest is if you try to pick a point, an easy point that you can tell what happened with the translation. Most of our graphs have a point at 0, 0, the origin. And that's this point right here. Isn't that point in between the 3 points that are right next to each other? Right? Which point on this graph is in between 3 points? This one right here, which happens to be 0, -3. So can't I see which was affected, the x or the y? Does everybody see that the y is the one that changed values? So if the y change values, does that occur outside the function or inside the function? Outside is y. Outside is y. Same direction or opposite direction? Or same sign, opposite sign? Same sign. So overall, it went down 3 units, didn't it? So here's how we're going to write the equation. We've got f of x is equal to, our f of x was x cubed. That's the overall basic function. We are going to affect it on the outside, so I didn't put any parentheses, and the outside is down 3. Same sign, -3. That's your equation. That's what they're looking for. Up-down movements occur outside that function. Jason, what's wrong? These ones here, I told you, I know what they are. So this is going to be given to you, this graph, but I wanted you to graph it correctly, so I gave you a repair so you could graph it correctly. You were not to know how to come up with this. You would be given the blue. You could, yeah, you could, it just depends. If they say function, especially function notation, you can't go wrong with these f of x. How did I know it was down 3? Because I'm comparing the same points on each of the graph. This is the point that's in the middle of these 3. So I chose this point that's in the middle of those 3. Right? Wouldn't they be the same points? Here and here? On each graph, sister points I'll call them. And so the only difference between these points is from here to here I went down 3. Just count. You okay with that? Everybody get that? Let's look at the next one. The next one I want you to plot the following ordered pairs. You're going to plot 5, 8, 4, 1, 3, 0, 2, -1, and 1, -8. So plot those points. So if you plot those points, you can see where the curve is coming through, and you can draw your curve right through those points. From the original to the new, you're writing the equation to the purple line. What happened? Did I go up, down, right, or left? Right. And so I'm going to compare this middle point right here, which is the origin, to this middle point right here, which is 3, 0. So right-left movements affect the x, and wasn't the x affected from 0, 0 to 3, 0? Now, if we are going right, 3, and so go ahead and write that up here, right 3. Same sign or opposite sign? Opposite sign, does that affect the inside or the outside of the function? The inside. So we're going to have f of x is equal to get inside the function, it's like we're doing fog or goth. I have to go inside, my x is inside, and I have to affect that x by the movement. Right is normally positive, so I'm going to go opposite sign, which is negative 3. And so this is the equation. Whoop, I missed my 3. I missed my 3, sorry. So this is the equation that we're looking for. So both movements have a -3 to them, but one movement was down 3, where this movement was right 3. They both have a -3. One's inside, one's outside. Two vastly different effects. Are we good with that before we hit on multiplying? All right, last one on this one. You're going to plot the points -3, +2, -2, +3, -1, +4, -4, -5. That's all that will really fit on this graph. So plot those. So we're missing the topmost point of this graph, so the assumption is that it's going through in this direction. So this graph move up, down, right, or left? It's all harder to tell, right? So look at your 2 points. This is my reference point, 0, 0, the origin. And this point right here, well, right here in the middle. This point right here in the middle is which point over here? That's -2, +3. Didn't both the x and the y change? So we have an up, down, or a right, left movement. So let's count. From the origin to get to this point, I must have gone left 1, 2, 2, correct? So I went left 2. And then from here I went up 1, 2, 3. Up 3. All I did was find a sister pair of points, one on each line, and just count the direction. So one's inside, one's outside. So f of x equals, I've got something affecting the x on the inside, and something's going to affect the whole function on the outside. Which of these two affect the inside? The left on the inside, the left 2, because the inside is your right-left movement, and that's the direction of the x-axis. So left is normally negative, but we want the opposite sign. So we're going to do, here's your x, we're going to do a +2. That means that the up, down, the up in this case is affecting the outside, and we want the same sign. Up is positive, so we want a +3. This is the equation of that line. And you can always put these in to check them on your calculator to see if they're accurate. Are we good with that? Pauline?
So the only number that you changed
Correct. Well, change signs as far as the direction that you're going. Technically, the order pairs, the x or the y always changes signs, but in the equation itself, only inside the function, in other words, what you're doing to the x when you do the opposite sign.
So on the task, you're giving us all the.
I would give you the colored ones that are here. You need to be able to recognize that it's a y equals x cubed basic graph, and if I were you, I'd be putting in the red. I'm not going to put the red in there for you, and you have to write that equation.
I write the version.
Yeah.
And then we like just tell you like left. To
I might ask you to describe the movement, and that's when you would use your words. If I don't, then I just want the equation. I will always write it down just because it helps me write out the equation itself. Any other questions? Okay, so flip this. Then we're going to look at reflections over the x and y axis. So again, I'm not big into memorization. I'm just trying to help you remember. How do I remember all these details? There's lots and lots of details in these first few chapters. So reflections across axes. I really only care about these two reflections. I threw in a reflection over the origin just in case you run into it. And think of it this way. If I reflect across the x-axis, so that would be, let's say, a point from here to a point to here. So going from here to here is across the x-axis, right? What value is changing, the x value or the y value? The y value. X-axis, the other value changes. And notice that if the y value changes, we are changing the sign of the y value to its opposite sign. So y changes to its negative sign in order to contribute the same distance across, just on opposite signs. So one's going to be positive and one's going to be negative. Because it's y and y is your output, we have to change the sign of the whole output for the equation of that function. So if we're going to reflect the entire function across the x-axis, not just a point, we're going to change the sign of the entire function because y is the output. So if we are going to reflect across the y-axis, so y-axis would be, for instance, a point from here to here. We would be going from this direction to this direction. What's being changed, the x or the y? The x is moving, right? And so again, it's the same distance from that y-axis, but one's a negative and one's a positive. So we are changing the sign of the x. So kind of that same theory of inside and outside. We are going to, when x is affected, it occurs inside the function. When y is affected, it occurs outside the function. The other thing that you can help to remember this is x-axis means y changes. It's just the opposite. Y-axis means x changes. When x has a change, it's inside. When y has a change, it's outside the function. That part has not changed. So I'm using that same philosophy all throughout this lesson. So let's look at example 3. Find an equation for the reflection of this lovely function across each axis. So you're not going to be able to, sit up Colin, you're not going to be able to use a calculator. There will be a non-calculator and a calculator portion to your test. All of this that we've done would be all non-calculator portions of your test. Most likely this entire section. So you might want to make a note of that. So if we're going to go across the x-axis, I'm thinking x-axis means there's a change in what? Y. Y occurs inside or outside the function? Outside the function. So I'm going to take the opposite of f of x. Well, that means that I'm going to take the opposite of the whole function. The whole function is 5x minus 9 all over x squared plus 3. I am perfectly happy with that answer. Math Excel, not sure if they're going to take that, you'll have to find out. But I feel that's a perfectly acceptable answer. you've got a negative hanging outside on the side of a fraction. Can't a negative hang out to the side or be put in the numerator or be put in the denominator but not both places? So this is an acceptable form of that fraction. If this were not a fraction, it were just 5x minus 9, would you be able to write it like that? No. So that's why it probably is not the best thing for you to leave it this way. Get in the habit of distributing that negative into the entire function. And in our case, when it's a fraction, you only distribute it to the numerator. So we are left with a negative 5x, a negative times a negative is a positive 9, all over x squared plus 3. That negative does not affect the denominator. To me, this is an acceptable answer. Your textbook, however, doesn't like the fact that a negative term comes first. You're going to see them switching these two around, so you have 9 minus 5x over x squared plus 3. Math Excel, I think, should accept both. I will accept this one, but only because it's a fraction, but you better make sure that that negative hanging out the side is quite obviously hanging out to the side. If I think or wonder if it's attached to that 5x or hanging out to the side, I will always assume that you put it next to the 5x. So, unless you're super clear about it, I wouldn't write your answer this way. So that one's the easier one. Reflecting across the y-axis can be a little more difficult. And here's why. That means that if I'm going across the y-axis, what's getting affected? The x. And the x always gets affected inside the function. So we are going to be putting a negative x into the function.
So if we were at the equation for
I would write it one of these two ways.
yeah, but would it be negative f of x equals, would it, if you wrote it negative?
Oh, you mean, no.
No, it would just be f of x.
Yeah, it would just be f of x.
Okay.
I see what you're saying. Yeah, if you were actually writing the equation of that reflection, it would just be f of x.
Okay.
Or they're going to call it like, I don't know, c sub 1 or c sub 2. They're going to give it like a sub number. Good question. All right, so I'm going to take the function. Everywhere that there's an x, I'm going to put parentheses. Because we're going to replace every single x with a negative x. It's almost like we are finding out whether this is an even or an odd function. Isn't that the same thing we did for that? Only a lot of you just left your answer, you left your work just like that. You actually have to calculate it out, so you got it wrong, by the way. You have to calculate it out. 5 times negative x is a negative 5x minus 9, all divided by negative x squared. It's a positive x squared plus 3. This is the only really acceptable answer. I guess you could switch the negative 5x and the negative 9 around, but who would? Why? So that one, as you can see, can get a little bit more complicated. So you can put these into your calculator to check them. Obviously, if you're taking the non-calculator portion, you're not going to have your calculator available, but I want you to see what happens. The original function I'm going to put in here using parentheses. So I've got 5x minus 9 divided by x squared plus 3. So this is an interesting graph. It's got a little blip there at the bottom. Let's do a little bit of review, left and right hand behavior. As x approaches positive infinity, what's the right hand behavior? I want to know what is y approaching. 0. Y is approaching 0 because it's hugging that x-axis. If it were going up, it'd be positive infinity, or down, it'd be negative infinity. But if it's hugging an axis, in this case, a horizontal asymptote, in this case, the x-axis, it's 0. What happens as x approaches negative infinity? What's the left-hand behavior? It's also approaching 0. So, thought I'd throw that in there. Now, let's put into y sub 2 the reflection over the x-axis. So I'm expecting it to flip down. 9 minus 5x divided by x squared plus 3. So there's the original, and there's the reflection. If you have those cool color graphing calculators, you can start to make some really pretty art with this. And there are actually artists out there that use mathematics to create their art, and that's their medium, so to speak. But if you're an artist and you like math, put it together. You get some really interesting pictures that way. So there's one. All you have to do is just keep doing, you can do a translation on that reflection, and you can keep changing where it is. You can do a rotation and we'll rotate it, all based upon the same equation. So let's take that one out, and let's put in the reflection over the y-axis. So parentheses, negative 5x minus 9 divided by x squared plus 3. There's the original, and here's the reflection over the y. It looks like it's a translation, doesn't it? But really what's happened is this original right here with the blip on the left side got flipped, and you can see that the minimum here is the same distance away from the y-axis as the minimum over here. And if I took the graph away, you'd see that this graph here is approaching 0 from underneath the graph, whereas originally it was approaching from above. And this side here from the original is approaching 0 from under the graph, and now it's approaching from above the graph. So it is truly a reflection. And that right there creates another interesting artistry that you can continue with. Questions about that before we move on to absolute value? This will be our last thing that we do today. Just so you all that can tell. Graphing absolute value can be difficult. There's an easy one, and the rest are all difficult. So let's just look at what I wrote here. So let's just start with a graph of y equals f of x, absolute value of f of x. I am taking the absolute value of the entire function there, aren't I? So the value of the function can be whatever we want it to do, but when the end comes, I want the absolute value of the answer. So what's going to happen to all y values? What kind of values are they going to be? Positive or 0. My y values cannot be negative because I'm taking the absolute value of the output, right? So that means that I can put whatever I want to in for the x. The x can be positive or negative, but the y had better come out to be positive when all is said and done. So what this says is it can be obtained by reflecting only the portion of the graph that's below the x-axis over the x-axis. So here's what that might look like. So here's my coordinate grid. Here's an example of what the graph could might be. So this is y equals f of x. Right now I have positive and negative values for x, but I have positive and negative values for y. If I took the absolute value of this graph, these negative values here for y would cease to be negative and become what? Positive. So what happens is this gets reflected over the x-axis, and the reflection looks like this. So my final graph for this would, I'm going to draw it over here, would look like this. If this is where it's crossing the x-axis, it's going to look like this. And this becomes y equals the absolute value of f of x. So that portion that was below the graph got flipped up. Yes?
This would be the next one. This would be what's on the test where, say, here's a graph showing as if it were absolute value.
I would probably give you this graph and have you draw it as the absolute, draw y equals the absolute value of f of x. And that I would expect that you would be able to do. And this is a question I could ask you. Exactly like that, I feel comfortable giving that to you on the test. The rest of them, probably extra credit. And you'll see why in a minute. So then, if we look at, well, what happens if the absolute value is just over the x? Right? That means I can choose any values I want to for x. I can still choose positive, negative, 0. That would be bad. Okay. So do you understand that I can put whatever value I want to for x into those absolute value signs of the function? Agreed or disagreed? I just have to take the absolute value of it before I run it through the function. I can choose whatever value I want to for x. So x can still be positive, negative, 0. But when it runs through the function, that value for that x will always end up being positive. So before I square it or cube it or add something or subtract something to it or divide it by something, that x will always be a positive number. Doesn't seem reasonable I can still come out with a negative y then? I can input a positive value into a function and still come out with a negative, can't I? 2 x minus 5. Can't I put in a 2 for x and get 2 minus 5 is negative 3? I can get a negative value. So let's explore how this might look, because this is what they said. Can be obtained by replacing the portion of the graph to the left of the y-axis by reflection. Now, the portion of the graph to the left of the y-axis, isn't that where x is negative? Okay, so far it makes sense. By reflection of the portion to the right of the y-axis across the y-axis, leaving the portion to the right of the y-axis unchanged. Lordy have mercy, right? Okay, so let's look at an example and see if we can make sense of that. So I meant to copy this for you, but yeah, it didn't happen. So here we go. So you have this equation or this graph up here, and you've got these 6 choices as to which one belongs to number 1, 2, 3, and 4. So 2 of the choices aren't it. So I'm going to put into my calculator that graph, and I'm just telling you right now that I know based upon the zeros, I have a 0 at negative 1 and a 0 at positive 2. And it's a problem. Won't it look like x plus or minus something times x plus or minus something? True or false? Let's go based upon the premise I'm putting something inside parentheses. Inside parentheses, same sign or opposite sign? Opposite sign. So if that 0 is negative, what's going to go in here? A positive 1. If x plus 1, if you set that equal to 0, won't it become a negative 1? 2 over 9. Okay. So the next one is what? X what? If it's a positive 2, it's a minus 2. Tell me if this is not that same graph. Did it work out? Okay, so we're going to use that graph, and then we're going to do the following things to it. We're going to take the absolute value of the entire function. So let's look to see what happens. What do you think is going to happen though? Let's just guess at first. If I take the absolute value of the whole function, what's getting affected, the x or the y? Can I put any x I want to into the function? Yeah. So the x is not affected. The x has negatives and positive values. So the y is being affected. How? It can't be negative. So your y value is going to come out positive or 0, right? So does this one show y as being all positive? No, because we got negative down here, right? How about this one? Nope. How about this one? This is a possibility. What about this one? That has no negatives. That's a possibility. But what did I teach you on this one? It would be, no, this one. For these two. If we were to determine which of these two it is, remember we took this graph, only it was a little bit more complicated on your notes, and what did we do with that part? We just flipped it up. Does that look like that part flipped up? Nope. So it's C. And then notice that E and F, well, this is all negatives, right? So that can't be it. And this has negatives and positives. And this has where the X's are all positives. All right, so let's see which one it is. So we're going to go into Y equals. It's a smidge of a nightmare, but I'm going to take that away. And I'm going to do absolute value. Actually, the nightmare is the last one. Parentheses x plus 1 times x minus 2. All of that's in the absolute value. So here we go. Sure enough, that's what happened, right? So, and this is the part you might be sketching down in your paper that you took out your note spiral for. So the absolute value of the function turns out to be c down here. All right, well, what happens if I just put the absolute value around the x in the function? This one's a bit of a pain. That means that, again, your x can be any value you want to, positive, negative, 0. Your y could be necessarily any value you want it to. So a lot of kids for this one are going to choose E because they're thinking, oh, the x has to be positive. so the x must always be positive. I can actually choose a negative x, then take the absolute value of it and run it through the function. So here's what happens. And this is the one that was complicated. So I'm going to take this one away. So it's not just a reflection over the y-axis. So I'm going to take the function, and instead of x, I have to put it in absolute value signs. And then plus 1. Right, so it looks like that. And then absolute value signs again. X, and then minus 2. Here's the graph. It almost looks like it's straight there, doesn't it? Are there any ones here where it's straight and below? Maybe here, or maybe here is one of those two. Let's zoom in and see what that really looks like. So hit trace, and then you can zoom in, enter. There's a little caret in there, isn't there? It went up at a little portion. Isn't that it right there? I don't expect you to be able to do that without a calculator. Just saying. So when you're looking at your notes that we just did, I want you to highlight this one. This is the one I expect you to be able to do. This one would be extra credit, and it would be extra credit in the sense that if it were a non-calculator portion, you just pick values for x, plug it into the function of the absolute values, come out with y's, and graph what you think it looks like. And you should be able to get that graph. Let's look at the last two. So I'm going to zoom out. What do you think this is going to do? The opposite of the absolute value of the whole function. That one was all positive, right? Doesn't that make it all negative? Won't it be this one down here? It's going to take this graph here and flip it so it's all negative. So that's what that one becomes. This one is a combination of number 2 and number 1. So here's number 2 and here's number 1. Wouldn't it be D? And that's